Hello and welcome to today's virtual JBoss user group. Today we've got Tom and Steph from the Ceylon project talking about Ceylon, and I'll just hand over to them.
Right. Hi, Steph.
Hi.
Hi, Tom.
Hi.
You can see me in the background. I'll mute my video.
All right.
Okay.
Hi. Thanks for coming. My name is Steph. I work on the Ceylon project.
I'm Tom. I also work on the Ceylon project.
Right. And we work on the Ceylon project now. So we're going to do a presentation today about. I can switch things here, right? About Ceylon, specifically about the ecosystem. This is where I have to share the screen, right?
Yes. Yeah. Did you do it now? It should be.
Entire screen. That works?
Yes.
Okay, excellent. So we're going to present Ceylon, the language, a new programming language, but not only the language, also the big picture around it, the ecosystem that's around it, and then also talk about the future. So we'll start with a brief introduction about who we are and what it is that we do on the Ceylon project, and then a quick intro about the language, and then we'll have Tom do lots of demos to illustrate what you can do with it, and in more hands-on than just talking about it abstractly. And we'll finish with a few words about the future of the Ceylon language. So, who we are. We work for Red Hat. We started working on Ceylon 3 years ago when Ceylon went public. Ceylon is the brainchild of Gavin King of Hibernate and CDI. He started the language, and then we started being interested in the language and joined the community, and were joined by other people who then started contributing to it as well. We are mostly spending our time on the JVM compiler. We'll see later on that we have another compiler. We also spend our time on the Vert module repository, which we will show in the demos later on. But generally, we're a bit the handyman of the project, and we work on the SDK, the tools, and making sure that all these things that fit together and work together nicely. So let's talk about the language a bit. Ceylon is a language, first and foremost. It's not just a language, but it is a language. It's a language that is powerful and modern. It's a language which is pretty much what you expect from a language that comes out this decade. So you can, when you see the language, you can notice that it is going to get rid of lots of boilerplate that you're used to, for instance, in Java. It's very inspired by Java as well, and especially all the good things that we like about Java, which is that it's a language that is easy to learn, easy to read. It is predictable, and Ceylon aims to do exactly the same thing. A language that is good to be working on teams, so that you can write code and you can read it again, which is something quite fundamental that we take for granted, but does not exist in every language. And I should know, I wrote a lot of Perl code in my life, and 5 minutes after you wrote it, if it's working, good, but if it's not, you just have to write it from scratch, because it's not possible to read it again. And you know, the same can be said of C++ back at the time, 20 years ago, when everybody was coding in C++ and Java came along and scrapped half the language. Have the features, was a lot less powerful, but then added a few things that made it coherent and easy to learn, easy to write, easy to maintain, and it caught on. And this is something that we are very attached to as well, making a language that you can learn and maintain. It's also an ecosystem. It's not just a language; it's a whole platform. We give you all the tools that you need to be able to write in Ceylon. It has modularity from the start, so modules are an inherent part of the language, very important in the language. And we have great tooling as well, which we'll demo later on. We have lots of tooling, and it's a language that is really meant to be toolable. So a few characteristics about the language. It's very inspired by Java, syntax-wise, and philosophically wise, I guess, as I would say. I have my English language mentor here checking what I'm saying, seeing if I don't start inventing words. And also C#, which is another language that has evolved a lot recently and has lots of cool features. It features, Ceylon features type inference, quite a lot of it, which means that even though it's a statically typed language, you do not repeat types all over the place like you would do in Java, where you end up repeating everything with square angle brackets and more type parameters. There's really a lot of type inference in Java in Ceylon, which allows you to type a lot less. Has a more powerful type system as well, with features such as union types, intersection types that we will talk about later on during the demos. It has float typing as well, which means that as you start working the execution flow within your language, then once you've checked that something is an instance of foo, then you can already use it as an instance of foo. You don't need to repeat yourself and start casting it and storing it in another variable, and it makes the language a lot easier to read and write. It has things that you expect from any modern language, such as mixins, lambdas, comprehensions, but it also has really unique things in this language, such as refi generics. Refi generics allows you to obtain at runtime the value of the type parameters that you were passed to your method. Java, for instance, has all these all these them away after compile time. So at runtime, you cannot know whether you have a list of string or a list of integer. You can make that distinction in Ceylon. This is quite handy. Very few languages have. We have as much as classes belong to packages in Java, then packages belong to modules in Ceylon. So, and it's in the language. It's really not a third-party tool that deals with modularity. The language knows how to deal with dependencies between modules, fetching dependencies from the network, publishing to the network. All the tools know how to deal with this. The command line, the IDE, this is something that is really core to the language. The SDK is modularized from the start. It's really something that is a key of the language. We have a great meta model as well, which is the equivalent of Java reflection, but then with lots of features on top of that. For instance, well, I think we'll discuss that during the demo, so there's no need talking about it too much here. We compile to the JVM, as I've already mentioned, but we also compile to the JavaScript language, which means that we can run Ceylon on Node.js, we can run Ceylon in the browser, and we can run Ceylon on the JVM. So it really means that we can run in lots of places, lots of interesting places. And it's the exact same language with the same semantics, with the same APIs, and it's not, half of the features are implemented. Everything works the same according to the specification, because we also have a specification in Ceylon. And of course, we have full interop with these two worlds. So you can, when you're compiling on the JVM, you can use the whole ecosystem that you love about the JVM and all the Java libraries. When you're running on JavaScript, you can use all the JavaScript libraries, and we have great interop, which we will demo later on. So the first piece of the ecosystem we're going to talk about is the Ceylon IDE, which we are going to spend a lot of time in during the demos. This is an Eclipse plugin that got started by David and Gavin King 2-3 years ago. So this is something that is also got started from the start. It's integrated with the JDT, which is the Java plugin, which means that you can have Java files and Java classes inside your Ceylon project, and they will work together. They will see each other, and you get the exact same editor you have for Java that you're used to. It supports everything that the command line supports. It compiles to JVM, JavaScript. It has lots of quick fixes, lots of refactorings, wizards. It is something that is integrated with the module system as well, which means that it's not just the equivalent of JDT, it's JDT plus the Maven module or the Gradle module or whatever you use to deal with modularity in your project. So it knows how to deal with modules, fetching dependencies, publishing them, etc. And it's definitely as production ready as the Java plugin, which is something that we do not say lightly because we've worked on it only 3 years. The Java plugin has been there for 15 years, and yet it is definitely as functional. It has at least as many features as the Java plugin, and we use it to code the SDK, and we spend a lot of time making it work, and it's really solid. We have another plugin for IntelliJ, which is a project got started by at the community again by Bastien and Mathieu. It's not quite as advanced as the Eclipse plugin. It has syntax coloring, compilation, navigation, execution, and many things. But it doesn't have all the refactorings, the quick fixes, the integration with the Java editor that the Eclipse plugin has. But the thing is that since the Eclipse plugin is pretty much feature complete, we've shifted development now to this, and this year we started ramping up development of it. So within the year, we hope to have something for J. And with this, I think I will let Tom do the demos.
Right. Thank you very much, Seth. Okay. So we were just talking about the IDE, the Eclipse plugin. So I'm going to demonstrate that, some of the features of that to you now. Just to explain what you're going to see, this first demonstration is going to feature a server-client architecture. So we've got a server which will be talking to a Postgres database over JDBC, demonstrating some interop with Java there. And we will be taking the results from that database, transforming it to JSON using one of the libraries from the SDK, and sending that over an HTTP server that's also in the SDK. And the client will be taking the HTTP response, does that via a WebSocket, so demonstrating some interoperability within the browser there, and also will be interoperating with jQuery and displaying the results in a web page. So we'll have a look at the server first of all. So the first thing we're going to look at is the module descriptor for this module. So we can see it's called server, very imaginatively, and it's version 1.0.0. And just like in, say, Maven, where you'd have a POM and you declare your dependencies, that's what we're doing here. So you can see the first 4 dependencies are all modules from the SDK. And then we've got Java base there. Java base, we use the same way of splitting up the JDK as Project Jigsaw does. So I don't know if you know about Project Jigsaw, but it's the effort to try to modularize the JDK. And Java base basically contains a lot of the core Java packages, so things like java.lang, Java util, Java IO, Java text. There's a lot of things in Java base, so by saying that we're importing Java base 7 there, we're basically saying we depend on Java 7. And the last one you can see there, the org.postgres, that's just the JDBC jar for Postgres. So let's have a look at what this module is actually going to do. We've got here a function called run. So that's the entry point to the module. When we run the module, it's the run function that we start off in. And at the start of the run function, we can see here that we're assigning a new value to the result of this get SQL function. So you see the value keyword here. That means that we're inferring the type. So the value SQL will have the same type as the result of the call to get SQL. And if we hover over this in the IDE, we can see what the type is going to be inferred as. In this case, it's going to be SQL. So SQL is an SQL object, logically enough. So let's have a look at the SQL function. Here we've got a top-level function in Ceylon. Functions don't have to be nested within classes as they do in Java. The first thing that we're doing here is we're instantiating a class. So we don't use the new keyword in Ceylon. A class is a callable thing, so just by invoking the class, we're creating an instance, and there's a bit more type inference going on there. The next few lines, if this was Java, you'd be seeing, we'd be calling setter methods here. So it would be source.setServerName, source.setDatabaseName. In Ceylon, we abstract over getters and setters. So it's the same sort of thing underneath, so you've got the same benefits in terms of polymorphism. If you need to subclass something, you can refine the getter, the attribute in exactly the same way as if you were using getters and setters, but we have a much more natural syntax. And at the bottom here, we're instantiating an SQL object, passing it a function, because functions are first-class objects in Ceylon. So the function is just getting a connection from the data source, and so that's what the getSQL function's doing. So we've got our SQL object, which is wrapping up a data source, and what we're doing now, well, we're creating a server with this WebSocket endpoint. So you can see in the doc cover there that WebSocket endpoint takes a whole bunch of parameters, lots of different callbacks going on there, but we're only passing 2 of them using this named argument invocation. So the first argument that we're passing is the path, which is going to match all the incoming URL requests for URLs beginning with /WebSocket. And the second argument here is a callback. So when the socket gets opened, we're going to be called back. This function will be called. We'll be given a channel to write the response to. And it's our job to fill in this response. How are we going to do that? Well, we're calling this readSQL function, passing the SQL object and another callback, which I'll come back to in a moment, but let's have a quick look at readSQL. Here it is. So it's taking that SQL object and this callback, and what are we doing? We're doing a SQL query on the database, so a fairly boring bit of SQL there. We're getting back a result set, which we're then iterating. So there's a bit more type inference going on here. In Java, you'd obviously have to say what the type of your iteration variable would be. Here we're just saying the compiler already knows the type. It knows the type of rows, so it knows how to iterate over rows without us having to repeat the type to it yet again. So if we hover on this in the IDE, we can see that the type of row is going to be a map. It's a map from string to object. Because it's a map from string to object, and we're going to want to be calling our callback with a string and an integer, we've got to downcast from object to string or integer. We do this using the is operator in Ceylon. So this is basically just a downcast in the same way as you might do in Java. In Java, you'd have to say if name instance of string, and then in the if block you'd have to do a cast, and you can end up having to write the type out 3 times if you're assigning in the if block to a new local variable. It can be quite repetitive, especially if you've got generics going on. In Ceylon, you just have to write the type once. So having downcast each of those, we just call the callback. So what callback are we calling that with? This one here. It's returning void, and what we do, the first thing we do is we instantiate a JSON object. That's a class from the SDK. You can see in the doc over here that JSON object takes a sequence of mappings from string to each of the JSON types there. So obviously the JSON format can support type string, boolean, number, null, other objects, and arrays. So those are the types in there. The thing to notice about this type expression here is it's a union type. So we've got string or boolean or integer or float. So we can specify very precisely what types the constructed to JSON object can accept. And if we try and pass something else, it's a compile time error. Think about what this API would have to look like in Java. We'd have to go for the common superclass of each of those JSON types, which very often, and in this particular case, would end up being java.lang.object. And immediately our API is not type safe anymore, because we're saying that we can accept an object, but actually we can only accept those JSON types. So because we've got a union type there, we can specify exactly which types our constructor is going to take. So we've got a JSON object. What are we going to do with it? Well, first of all, we're going to print something out so that we can see this thing as it makes its progress with the requests and responses. And you can see here we've got some string interpolation going on. So in Ceylon, we use double backticks to enclose expressions within what would otherwise be a string literal, and those expressions are evaluated to come up with the string to print there. Having done that, what are we doing? Well, we're pretty printing the JSON and sending it as text over the channel. And then lastly, we're just going to sleep for half a second so things don't all happen at once and we can see how things progress. So we've created that server. The last thing we have to do is to start it, which is the last line in the run method function, rather. So having done that, we'll run that. And we can see it started there, and now we'll go and have a look at the client, which is
Next project.
It's the next project, this one. Yay. So let's start off in the module descriptor for the client here. A lot simpler than the last one, but the thing to notice is it's exactly the same module we're using in the client, so in the web browser, as we were using on the server side. It's ceylon.json. So having learned that API once and using it on the server side, we can use that knowledge again in the browser. So let's have a look at the run function of the client. The first thing we notice here very prominently is the dynamic keyword. What's that about? Well, we're interoperating with some JavaScript here. And of course, JavaScript is a dynamically typed language. There's no type information available at compile time that we can use to validate the code that we've got here. So we need to tell the compiler that that's the case, that there isn't the type information, so it can't type check the code. So when you see dynamic, it's basically just telling the type checker that that's the case. And it will take it on trust when we try to invoke a method on something. It'll take it on trust that that method exists and we're calling it appropriately. And if we're wrong, it will fail at runtime, just as it would if you were writing JavaScript. So the first thing we're actually doing is we're instantiating a WebSocket from the browser's native API. And we're then also selecting, using jQuery, a div with the ID target. So we've got the socket, and we're going to set its onMessage callback to this function here, which takes a dynamic parameter. And it's taking it on trust that data is indeed a member of event. There's no way the compiler can check that, but it's letting us do that because we've told it that we want to do that. We're calling the parse JSON function here, which is from the SDK, which is returning us one of the JSON objects we saw earlier. And we're having to say it is a JSON object, because obviously JSON can be any of the JSON types. It could be an array, it could be a string, so we have to say that we're expecting some JSON, a JSON object rather. And then we're treating that JSON object as a map, so we're able to index into it using the index or subscript notation here, just as we would any other map in Ceylon. And we're pulling out the name, the version, the downloads, keys from that JSON object, and again we're having to downcast those using the is operator. Now, the type of this JSON map, again, the map values can only be the JSON types. So it's a compile time error if I try and use it with one of the types which isn't in JSON. So for example, byte, it's a compile time error, we can't do it. Again, demonstrating that the union types are quite useful for saying exactly what types are the mapped elements in the JSON object there. So we've then got a couple of calls to jQuery to construct some elements that we're going to be populating in the page using the data that we've pulled back, so the name and the version, and we add it to the document and we fade it in. So let's have a look at, not that one, there we go. So there's the button that we select with the jQuery. We click it, and if I just switch back, we can see it's the server that's serving up those. Just to round out the demo, what does the HTML look like? Well, it looks a lot like normal HTML, to be honest. So we've got some style sheets in there. Because we're using jQuery, we're having to make that available using the script tag. On JavaScript, in the browser, we build on top of require.js for the module system. So that's why that's there, and we have to configure it to tell it where the Ceylon modules are coming from. We've got a little bit of jQuery here just to actually load the module when the page loads, and also to set up a callback so that when I click on the button, it will run the module. And right at the bottom, we've actually got a couple of elements there. So we've got the button that we click on and the target div that we fill. So having seen a little bit of the IDE and a little bit of the SDK and things going on there, let's talk a little bit more about the SDK. So the only module that ships with Ceylon is the language module. So this defines all the basic concrete types that you expect to have to use all the time, things like string and integer. And one thing to say on the JVM is, although in Ceylon everything is an object, we don't have primitive types, the compiler will optimize two primitive types whenever it can. So if you write a function that takes an integer, it will compile down to a method that takes a long. Likewise, float will compile down to double, and so on and so forth. As well as those concrete types, we've got interfaces for the common collection types, set, list, and map. We don't supply implementations in the language module. That's left for people that want to provide different implementations, so you get to choose. In Ceylon, quite a few of the language constructs, such as operators, are defined in terms of interfaces. So, for example, the plus operator is defined in terms of the summable interface. And likewise, we saw that we were treating the JSON object as a map. Well, that index notation that we're using to look up a key in a map there is the correspondence interface. We also saw some first-class functions being passed around. Those correspond to the callable interface in Ceylon, and we also supply some functions to do higher order things with callables. So, for instance, we can apply them and we can compose them and things like that. In the language module, we also supply information about the runtime that you're running on, and the version of the language, and also the meta model, which Steph touched on before. So, the language module aside, what is there in the SDK? Well, you can see a list of the SDK modules there. There's quite a few different things going on. The main thing to say, I guess, is that the ones with stars are only available on the JVM. Obviously, we'd much rather modules were available on both the back-end platforms that we support, but in some cases it just doesn't make sense. So, for example, with ceylon.file, obviously in the browser there is no file API that we can build on top of, so we're never going to be able to provide ceylon.file for JavaScript. It's always going to be a JVM only thing. But there are other examples there, such as ceylon.math, which currently is based on the Java classes big integer and big decimal. We're hoping shortly to be providing pure Ceylon implementations of those. So some of them are a work in progress and might become available on JS shortly, but some of them never will be for very good reasons. And now I'm going to talk a little bit about the command line interface, because if you're like me, you spend quite a lot of time in the IDE, but also a lot of time in at the command line. So we wanted the command line tools to have a really nice interface, and we felt that Git got things right there. There's obviously just the one Git command with lots of different subcommands, and that's the sort of the pattern that we've copied. So there's one Ceylon command that you can use, and there's a whole bunch of different subcommands. These can be extended after you've sort of installed Ceylon using scripts. So there are a couple of scripts. For instance, the ceylon.test command is a plugin, and we'll be seeing Ceylon build shortly in another demo. and that's also a plugin into the main Ceylon command. One of the benefits of having the single command is it aids discoverability. So for instance, when you download the JDK, you get a whole load of tools, most of which you probably don't even know about, because how do you find out about them? You know, we all know about Java-C and Java for running our programs, but I think quite a lot of people are surprised when it turns out that JVM is there in the JDK, but it's not sort of very discoverable. Well, we've got tab completion, so you just type Ceylon, hit tab, and you can see all the different commands that are available. And there instantly you've got context-sensitive help. You can say Ceylon help compile. Just like in Git, you'll get the documentation for these compile command. And that help information can also be exported to different formats. So let's have a look at that. Kill that. So I'll just very quickly show you the module that we're going to use to demonstrate this. I don't think there's very much. It's the same sort of things in the module descriptor as we've already seen. What's this going to do? It's going to, we've got a copy of the GitHub API running locally on this machine because we don't like the network ruining our demos. So what it's doing is we're going to be making a GET request to that API, passing it as JSON, iterating over the JSON object in the returned array, extract some stuff, and printing things out to the console. So not particularly exciting. You get the idea. So in Ceylon, the source files all exist in the source folder. Tell you what, I'll switch to the console and we can have a look. So there are the source files from a few different modules in this directory here, and when we compile things, the output goes to a folder called modules. But let's have a go at compiling it. So I said we have command line completion. There we go. We've got a list of the available subcommands here, and you can see there's a whole bunch of them. There's compile and compile.js, depending on which backend you want to compile to. Run and run.js for executing on different backends. There's the doc tool. Yeah, you get the idea. So by default, if I say Ceylon compile, it will compile all the modules in the source folder. Note I'm not having to say anything about class paths here and source locations and destination locations. We don't have to specify a class path because we've got the module descriptor. The tools all know about module descriptors and how to look up modules from module repositories, so we can just say Ceylon compile, and it does the right thing. If we want to just compile one of the modules, we just say which module we want to do that. And we just compile the one. So as a result of that, we've got the in the modules is a output repository existing on the file system, and we can see what we've compiled here. And you can see that we've compiled. Actually, that's not the right one.
Sorry, press interruption.
Yeah.
Click on the hide button at the bottom of the screen.
That would make my life slightly easier.
That's what people see when you're typing as well.
Okay, so we've got here in the modules, we've got a module repository going on, and you can see we've generated a car file. Car file is just the same thing as a jar file, just as a different extension. But if we want to have a look in there, it's got the class files in there, and it's got the usual sort of meta-inf type stuff. So one thing to say is we're not scattering class paths all over the file system to find later and think, what was this? When did I compile this? How out of date is it? So we have compiled it. Let's run it. Run, that's for later. There we go. It's doing what I said it was going to do. It's getting some issues over JSON, HTTP there. Another thing to note, again, not having to specify the class path because we already know where everything is. The dependencies, it's all there. It's all nice and simple to use. Okay. So we've got nice command line tools, but often we don't actually use the command line tools directly because we want to script the build. We want a nice repeatable build that we can share with our team rather than running stuff all the time interactively at the console. So we want a build tool. Well, there was a guy in the community, Loïc Rouchon, who was interested in this and was inspired by the way Gradle does things. So in Gradle, if you're not aware, you can script your build using Groovy, and obviously you've got the complete power of a programming language, so you can get it to do whatever you want. And he felt that Ceylon would benefit from the same sort of thing. So ceylon.build allows you to write a build in Ceylon itself. So let's have a look at that. So it's applying the same sort of convention over configuration. There's a build folder which contains a module called build, which will be used to run the build. So there's two modules being imported here. There's the Ceylon build engine that provides the core of the build tool and also the annotations which we'll be using in order to write our build. And the second one there, the Ceylon build task Ceylon, that provides the same tools as we have on the command line, but it's a Ceylon API for those. So let's have a look at the build here. So we're defining a top-level string there, which is just the name of the module that we're going to be compiling. And we've got a very simple goal here. So it's annotated goal. That's an annotation. We don't use the @ in Ceylon like Java does. Annotations and shared is another example. Read a lot like modifiers, but they can have arguments just like Java annotations. So we've got a top-level function, annotated goal, called compile, and so when we want to run the build to do the compile step, that's what we're going to call it. So one thing that we do here is we output some logging information just to show that something's happening, and we call Ceylon compile with the name of that module. So let's have a go at that. So I call Ceylon build compile. There we go. It's printing out the debug information, and it's created the module. I've just realised I didn't show you the interactive help before, so I'll do that now. So I said we had interactive help and things were discoverable and stuff. So we've got the help there for Ceylon compile formatted as a man page. So it's all available there in the command line for you, and you know the plugins too. They're documented, so I could say Ceylon help build, and we get the same sort of thing. So next, I want to talk about the herd. The herd is a module repository, so think of it a bit like Maven Central. But we wanted it to be really nice, and we were inspired this time by GitHub, because I don't know if any of you, some of you I'm sure, will remember what life was like before GitHub, working collaboratively. Things like SourceForge were hardly a model of usability, whereas GitHub came along and they obviously put a lot of effort into their user experience, and it shows. We wanted the herd to be like that, so we've also put a lot of effort into our user experience. As well as the nice UI though, we've got a REST API like GitHub, which we use ourselves in the IDE and the command line, but it's also available for anyone else that needs to use it. When you publish a module in herd, you do so to a staging repository. The reason you do that is the herd wants to validate that the module is all fully formed and you've not broken any rules, you've not uploaded rubbish, you're not going to annoy people by doing things like uploading a module but not actually uploading the dependencies. That would be a bit annoying. So you upload to a staging area, it checks it, and then you publish it from there.
So can anybody do this?
You have to, yeah, basically yes, you have to register, but yeah, it's open to anyone to use, and it's open source software, so if you want to run your own module repository, you can do so.
Okay, and then for the module, so is it compiled modules that go there, or does the source go as well?
You can choose. Obviously, if you don't have open source software, you could just deploy your closed source. I think the herd that we run has the policy that it has to be open source, basically. Yeah. But obviously, if you're running your own, you don't have to. But by default, I think the source does get uploaded too.
So is that the kind of standard model that if you want to use the service for free,
yeah,
it's free for open source use, but if you want to have closed source things on there, then
that you'd have to be hosting your own. Yeah. So it's not just a lonely thing that you do on your own, though. So if you've got a team, then anyone in your team might be enabled to publish modules. And there's a social aspect as well, so you can comment on modules, you can give them star ratings, and you can also subscribe to RSS feeds so you know when certain dependencies of your module have new versions. So this is what the herd looks like. I'll just hide that again. So we can find modules. Is the easiest way to find modules if you know the name is up here, but we can also see them by category, list them, find the popular ones, that sort of thing. We'll have a look here at the SDK modules. So we can see immediately which ones they are and whether they're available for JavaScript as well as the JVM. Let's drill down into Ceylon collection. We can see how often it's been downloaded. We can see all the different versions that have ever been published. We can browse the files, or we can look at the docs. So I was talking about the documentation generator earlier when I was doing the command line demo. Well, this is the sort of documentation it's generating. We've got keyboard shortcuts. We can search for stuff. So if you're used to browsing JavaDoc, it can be quite frustrating having to trawl backwards and forwards trying to find things. So with the search, it's a lot easier to find what you're looking for. That's what a module that you might want to use looks like. But what if you want to publish your own? How do you do that? Well, first of all, you need to register for an account. I'm not going to do that. I'm just going to log in using Steph's account already and do any amount of damage. And then what do we do? Well, it's explained here. We've already registered. We've already got our username and password, that sort of thing. You have to claim your project. So that's basically just to stop people from trying to publish stuff that they aren't really associated with. So we don't want anyone random coming along and trying to publish an SDK module, for instance. So you lay claim to a particular namespace, and if you can prove that you own that domain, or you're associated with that namespace some other way, then you get that namespace and you can publish stuff to it. So once you've done that, you can upload your module. So I was talking about staging repositories before. Well, this URL here is the URL for the staging repository that we're going to be uploading to. There's some helpful stuff here about how to use the command line tools to publish straight to this staging repository. For JavaScript, and we also supply Ant tools, so we've got some help there on the Ant, but we're going to be using Ceylon build. And here's a slightly more complicated goal that we're going to be using. So one of the benefits of using a programming language is we can interact over the standard input. Which is what we're going to be doing here. So we're going to be taking the URL that we just saw there and requesting a username and password. Obviously, we wouldn't normally want to put this in a build file, hard-coded passwords in build files, which we then commit to GitHub is probably not a good idea. Immediately sharing our credentials with the rest of the world. Might want to do that, so we'll get it over the standard input. And you can see here we're going to compile the module that we sealed before, direct to that staging repository, and we're also going to run the documentation compiler as well. So I say Ceylon build publish. I'll give it that. Tend to be Steph. I always get this wrong. So there you go. It's compiling and documenting straight to that staging repository. So if we reload, that's not supposed to happen.
We forgot to bump the version number.
Ah, right. Okay. Thank you.
What happened there? What did you do wrong?
From the last demo. From the last demo, we haven't incremented the version number, so you can't publish the same version again. So I need. Let's get this one.
It tells you. It says, well, you already published that version. You're not going to publish it again.
Great.
So we'll save that one.
Very dangerous. People do that. Version numbers are cheap.
So can I just publish straight to this repo again, or do I? Yeah.
Can't fix it. It's interactive.
Okay. So I run that again. I say that. It means I've got to try and get the password right a second time. And it worked again. And this time, this is going to work, right, Steph?
Oh, it works. You have two modules, which is
So I just delete this one.
get rid of this one.
And now I can look at the diagnostics of this one. So I said that the herd did some checks. You can see the sort of checks that we've got here. So it's checking that the module is one that I'm allowed to publish, that it's got a valid module descriptor, that the dependencies are already there, that it's documented. The one thing it's warning about, it's not a fatal error, but it's saying that we've not published a JavaScript version. Well, that's not exactly a problem for this demo. Where's my publish button, Steph?
H below.
There we go. Click publish. It's published. There it is, version 17, hot off the press 8 seconds ago. I said we generated the documentation, so there it is. There's not much of it, but it's there. So that is a very brief introduction to the herd. And now I'm going to talk about Vertex and Kyla. So Vert.x well, it was started by a guy called Tim Fox. The idea behind Vert.x is it's reactive asynchronous programming, just like Node.js, but it's in Java. And a guy called Julian Viet from the community thought this was a good idea and that we should have this available in Ceylon. And so he's written the bits and pieces that we need to do that. So the first thing we need to do asynchronous programming is promises API. So there is a specification called the A+ specification for promise-based asynchronous programming. This has been implemented in a whole range of programming languages, and ceylon.promise is the module which implements it for Ceylon. The next bit that we need is the integration with Vert.x. So this works in two different ways. You can start a Vert.x from Ceylon, and you can also provide your Ceylon verticals in Ceylon source code, and the Vert.x container will compile and deploy them for you automatically. And the last bit we've got here is a whole web framework called Cayla, which builds on top of Vert.x and makes it all nice and easy to use in Ceylon. So I now have a demo of this. It's the same project, is it? There we go. So the first thing to notice here is the module descriptor. It's quite a simple one. I said Kyla was a web framework, so we're just importing the web framework. We're not having to download it and unzip it in the right place and configure it and configure the class path to know where it is and all of this sort of stuff. We're just importing Kyla, and it's immediately there available for us. So in Kyla, what we do is we've got something here which is a handler, which is annotated with root. So any request coming in which matches that pattern in the root annotation there, because this is a handler, this is the thing that will handle that request. What does it do? Well, the invoke method will get called. The thing that is interesting about that is it's not actually returning a response, it's returning the promise of a response to be fulfilled as we go along. It's taking this request context, and we're creating an HTTP client from it. And we're making a call to the Chuck Norris quotes database, which we've got running locally because, again, we don't like network ruining our demos. So what do we do with that request? Well, the first thing to notice about that request, we get the response from that request. We don't actually get the response. We get a promise of a response. We then compose this with this function here. So when the promise is fulfilled, we've got the response, which is an actual response at that point, and we pass the body. But that's returning the promise of some JSON. So when that promise is fulfilled, we've got this transform here, which will take the JSON object, pull a couple of things from it, and call this, well, return an OK response with the result of this index function. Let's have a quick look at that. Oh, there we go. So here's this function index, which is returning a template. And we're passing in the joke. And we can see immediately what's going on. We're obviously creating some HTML. And we can see the structure of the HTML. It's completely obvious. Think what this would look like in Java. We're creating a tree of objects, and we've got to instantiate one. We want to set a reference to another one, so we end up having to write the whole thing backwards. And we come back to this in a couple of weeks, and we look at this mess, and we think, I can't remember what the structure of this is. Well, come back to this in a couple of weeks, and we can see immediately what the structure of this is. It's there for us. This looks a bit like a DSL, right? But it's not. It's all instantiations of classes. There's nothing more than creating instances going on here, calling initializers with named argument syntax. So we can see the joke gets put in this paragraph at the bottom here. We return that, returning the OK response. Ah, thank you. So I forgot to show you the last bit at the bottom where we actually start the module, the run method. What's it doing? The first thing to notice here is we're passing a package literal. We're all used to class literals in Java where we say foo.class. Well, in Ceylon we've got literals for other things as well. We've got obviously class literals, but we've got package and module literals, and we can have function and value literals as well. So what Cayla does when we start it up is it scans that package for all the handlers which are annotated root, and it builds them into the server. So when we run it, which I've not done, that's what it's going to do when I do run it.
Also, the meta model lets you scan the package,
yeah,
scan the module, which you cannot do in Java.
Yeah, in Java, if you've ever looked at the API for the package class, it's practically speaking useless. You can't find out all the classes in that package, but you can do this in Ceylon. So it's very easy to write frameworks such as this, where we just pass in the package. So, for example, the test framework does the same thing. We want to run all the tests in a package. We just say we want to run all the tests in the package. It's dead easy for that framework to then find out where all those tests are and to run them. Now, finally, I can show you the Chuck Norris quotes. What you all came here tonight to see, right? So it's all happening asynchronously on the server there in response to the request coming in. Okay, and now I get to pass back to Steph.
Right. So the last part is going to be about the future of Ceylon. In order to better understand the future, it's always good to understand what happened just before the future. So we released version 1.0 of the language and all the tools that you've seen tonight a year and a few months ago, at the end of 2013. Version 1.1 was released a couple months ago in October. It's a release that's that focused very much on bug fixes, improving compilation time, memory usage, and performance of the IDE. We polished a lot the IDE. This is where we made it really great. But there's very little changes in the language, and we did this on purpose, other than much better Java interop. release. What we are working on really hard now is version 1.2, where we have a number of new features in the language, all of which are already implemented as we speak. This is not vaporware. We have this working. We are now in the process of polishing the release. We have serialization, for instance, the first big version, first big feature in this thing, which allows us to take an object when we are running, say, in the JavaScript VM, and then send it to another process running on the Java VM. So you're able to send objects from client to the server very easily with serialization. We have better float typing within expressions. The float typing we showed you earlier was going on inside the function statement to statement. Now we can also float type inside expressions, so it's very handy. We also have better float typing in the else block, so that now if you're entering an if block and you say, is this an instance of that, then within the if it's going to be an instance of that, and within the else it's going to be an instance of the rest. We have let expressions to allow you to declare a new variable inside the middle of an expression, which can be handy. Multiple constructors, because the default way to write a class in Ceylon is to say that the body of the class is the constructor, because in most cases you only need one constructor in your class, so we made it possible to write this really with the minimum amount of boilerplate. In some rare cases you will need 2 or 3 constructors, and in this case then it is supported in this release. We haven't talked about tuples, but we support tuples, which is a group of elements with different types. So if you want to return more than one return value in Ceylon, it's trivial. We support now tuple destructuring, which means that you can assign destructor a tuple that you got from a function and assign it to several variables, and they're all filled in with the elements of the tuple. And a number of other things that we didn't have room to put in there. And by the end of the year, hopefully, we'll have version 1.3 with, again, new features. The biggest one of which is probably going to be assemblies, which is in much the same way that a module is a collection of packages. Then an assembly will be a collection of modules. It will represent an application and how these modules interact together. Well, AST transformers will also be nice. This is something that is supposed to be the same thing as APT compiler plugins, but then done right, where they're actually able to modify the AST and not just look and cry. Link style comprehensions would be interesting as well. If you've done any C#, then you know what link is. It's a way to have a type-safe way to write type-safe SQL statements in the language, which will then be checked. That's pretty nice, and that's something we hope to do with AST transformers. The bit which we always forget to say is that all of this is available. It's open source. Everything is on GitHub. All the tools that we showed you, all the Cayla, Herd, the IDE, the command line, the distribution, everything is open source. So if you want to use it, then it's free. You can. If you want to contribute to it, then it's even better. And we have great tutorials on our website, a whole guide about the language if you want to learn it. We're on IRC as well if you want to ask questions, and then we have a mailing list, and we hope to have feedback if you have any. And if you have any questions, then now is the time. We have time for questions, right?
Yeah, absolutely. Yes. Go for it.
Excellent.
Yeah. Gonna switch to the next question. You probably want to switch to a different tab as well.
Do I?
Otherwise, you're going to see.
Okay. Well, I can switch back to this one. Any question here?
So I've got some questions if nobody else has.
All right.
One second.
such thing in Java. So there is a bit of machinery around it, basically which create a class with the same name as the function. It has a static method with the same name as the function, and that's where we put the code. So in most cases, it's quite obvious what it would be. And so on both sides, it's quite easy to do interop. Calling Ceylon from Java is straightforward, and the opposite as well.
Yeah.
Yeah, sure. Absolutely.
For the link style comprehension, so I think we probably
No more questions? Okay. Okay. So.
Thanks for coming.
Okay. Thanks for watching the virtual JBoss, and we'll see you on the next session. Bye bye.
Bye.